In electrolysis, we are using electrical energy to generate a non-spontaneous chemical reaction. In this case, the non-spontaneous meaning that we are using external forces to induce a redox reactions. So in a typical electrolytic cell, we have here a battery connected to two electrodes, and the first electrode here, anode, will be connected to positive terminal of the battery, and the second electrode will be connected to a negative terminal of the battery. So the electrolyte used in this system is molten sodium chloride. So when the system is provided with the electrical energy, so the molten or the pure sodium chloride will be dissociated into two ions, which is anions and cations. Okay, the anions, the negative anions, will be attracted to the anode terminal here, which is the chloride ions, and then at cathode, the sodium cation will be attracted to the cathode terminal. At anode, there will be oxidation process occur, and at cathode there will be reduction process occur. Here the chlorine gas is released, and at reduction process the sodium metal is produced. So to form a overall redox reaction, here we have to balance the electron for both of the equation, half fractions here. So when you cancel out the electrons on both sides of the half fractions, you will get the overall redox reaction here, where 2Cl minus plus 2Na producing chlorine gas and metal, sodium metal. This is an opposite system to the galvanic cell. There are three factors that affect the electrolysis process. The first one is the position of ions in electrochemical series. This one we are going to see the standard reduction potential for half fraction that involved in the system, where either the standard reduction potential is more positive or more negative. The secondly is the types of electrode used in the system. Either it is inert or active electrode. Inert electrode can be carbon graphite and platinum, while active electrode can be copper or zinc electrode. The thirdly is the concentration of the electrolyte used in the system. The higher the concentration of the electrolytes, the higher its possibility to be undergo reduction, even though the standard reduction potential is less positive. Now we look at the first factor that affect the electrolysis process. The first one is the position of ions in electrochemical series. So we have here a typical setup for electrolysis process, but in this case we are using aqueous sodium chloride as the electrolyte, and in the electrolyte we have Na plus, Cl minus, and water molecule. Okay, at anode we know that there will be oxidation process to occur, and at cathode there will be reduction process to occur. At cathode there will be competing between cations, where the cation, the positive ion, will be attracted to the negative terminal of the electrodes. So here we have sodium plus or H plus or water molecule. So when we compare the standard reduction potential value for both of the half fraction, we have here Na plus having minus 2.71 volt, while water will have minus 0.83 volt. Comparing between these two values, we can see that the water will undergo reduction process because it is more positive values, while at anode we can see that the chloride ion will turn to chlorine gas, and the oxidation of water molecule is having minus 1.23 volt, while the chloride ion will have minus 1.36 volt. So comparing both of the system, both of the half fraction, here we can see that chloride ion producing more negative value of the standard reduction potential. So we select the chloride ion to produce chlorine ion here. So both of the half fraction will be selected to produce overall redox reaction here, 2Cl minus plus 2H2O producing chlorine gas, hydrogen gas, and 2OH minus. Second factor that can affect the electrolysis is by the use of different types of electrodes in the electrolysis system. So in this case, we are using copper electrodes for both anode and cathode. So the electrolyte used in this system is the aqueous copper sulfate. So in the electrolyte, we have copper 2 plus and SO4 2 minus and water molecule. However, at cathode, there will be a reduction happen where the copper 2 plus will receive the electron and becoming copper solid. So in this case, the electrode at cathode will be increased because the copper 2 plus deposited on the electrode. While at anode, the electrode will undergo oxidation, where the copper will become copper 2 plus. So the mass of the electrode at anode will be decreasing. It is undergo corrosion. This happens when we are using copper electrodes as the active electrodes for both anode and cathode. However, when we are using carbon electrodes for both anode and cathode, the inert electrode, there will be different results at anode, whereby the water molecule will undergo oxidation to produce oxygen gas. However, when we are using carbon electrodes at cathode, the result will be the same. The third factor that can affect the electrolysis is the concentration of electrolytes used in the system. For example, here we are using concentrated sodium chloride as the electrolyte. So in the electrolyte, we have Na+, Cl-, and water molecule. So at the cathode electrode, there will be reduction of water molecule to produce hydrogen gas. This is because even though the concentration of Na is high in the solution, we compare the standard reduction potential for both Na and water. So in this case, water molecule having more positive values compared to Na. So at the anode, there will be oxidation of chloride ion to produce chlorine gas. So overall of redox reaction here, we can write like this, where 2Cl- plus 2H2O producing chlorine gas, hydrogen gas, and 2OH-.